So today we are going to proceed to learn how we can find the equation or obtain the equation of a straight line if you have um, two given points. Okay. Okay, so the idea remains very simple. It has been the same. Just give me a second. So it has been the same idea we've been using so far. So let's say we have our x and y axis. So here we have y-axis and here we have the x-axis. So let's say we have a straight line as always. And on this straight line we have the point A here. Let's call this point A. Let's call this point right here point C. Point A is going to be x1, y1 based on our understanding, and point C is going to be x2 and y2. Now let's say we have another arbitrary point somewhere in between. Let's call this point point B. Now this point is just going to be x, y, because it is a variable. x1, y1 is not a variable. x2, y2 is also not a variable point, but the one right here in the middle, which is B, is a variable point. Okay, so if we take 2 points at a time, let's say we are trying to take A and C together. So we have a line, then we have this as well. Remember that this is the rise and this is going to be y2 minus y1, and here at the bottom we have the run, which is going to be x2 minus x1. The formula for slope, m, is equal to y2 minus y1 over x2 minus x1. Now we have been able to take the two extreme points, that is point A and point C. Now let's look at the other point here in the middle. So for this middle point, I'm going to pick this middle point along with point A here. Okay, something like this. So here, since it is not y2, here we have y2 minus y1, right? Here is just y. So you're going to be having y minus y1, since we are picking it along with this one, and this is going to be x minus x1. Remember that the same way you had the slope for AC, which is m, it is the same m you are going to be having for AB. So this means that for the second case, which is AB, m is equal to, you have the rise y minus y1 over the run x minus x1. Moving forward, if you look at the first instance, we have just m. If you look at the second instance, we also have m. So m is equal to m basically. Okay, so the first m, which is y2 minus y1 over x2 minus x1, is equal to the second m, which is y minus y1 over x minus x1. This is the formula for obtaining the equation of a straight line if you have two given points. I want to believe that is clear. And let's apply this understanding to our formula. To our examples. In example 1, don't forget that the formula we are using is y2 minus y1 over x2 minus x1 is equal to y minus y1 over x minus x1. That's the formula we are using. Now we want to find the equation of the line through 2, negative 3 and negative 1, 4. So what we do is to write out our coordinates. We have the first point, which is 2, minus 3. And the second one, we have minus 1, 4. So what we are going to do, as always, is to call this x1, y1. This is going to be x2, and the next one is going to be y2. After that, we plug in these values into the equation that we have. So how do we do that? We start, y2 is 4, so we have 4 minus y1 is minus 3, so we have minus 3 over x2 is minus 1, so we have minus 1, and x1 is 2, so we have minus 2. This equals to y minus y1 again, that is minus 3, over x minus x1, which is 2. Now, there are two negatives here. That makes it positive. So you have 4 plus 3 over minus 3 is equal to y plus 3 over x minus 2. 4 plus 3 is 7. So we have 7 over minus 3 is equal to y plus 3 over x minus 2. The next thing to do here is to cross multiply. Now, during the process of your cross multiplication or what have you, you might choose from there. You might choose which variable you want to be on the left hand side and the other on the right hand side. Now, for me, I want my y to be on the left hand side, so I'm going to cross multiply my y first. That is, I have minus 3 multiplied by y plus 3. The next is 7 multiplying x plus 2. So we have 7 multiplied by x minus 2 rather. When you open the bracket, you have minus 3y minus 9 is equal to 7x minus 14. Now, it's all your choice. It depends on you. You can decide to pick your minus 9 and take it to the other side. So you have minus 3y minus 9, is equal to 7x minus 14 plus 9. So I'm going to proceed here. I have minus 3y is equal to 7x minus 5. You can choose to stop here if you find it confusing moving this negative from one point to the other. You can just leave it that way, okay? Or if you don't want it to be this way, okay, you can multiply through by minus. So when you multiply through by minus, all the minuses becomes plus, and the plus that you have here becomes minus. So if I multiply through, I have 3y is equal to minus 7x plus 5. This is the equation of the line passing through 2, negative 3 and minus 1, 4. In question 2, however, we are expected to find the equation of the line passing through this and this. So Let me give it another try again so that those that don't understand the first example can follow the second example. We have again y2 minus y1 over x2 minus x1, which is equal to y minus y1 over x minus x1. Now we are picking these 2 points to begin with. So we have 3, negative, then we have 2, and then we have 5, 2. Plug in your values. Right. So first we need to say that this is x1, y1, and this is x2 and y2. y2 is 2 and y1 is 2 as well. x2 is 5, so we have 5, while x1 is minus 3, so we have minus 3. And this equals to y minus 2 over x minus minus 3. You will notice a particular pattern in our workings, that what we have on this side is usually what happens on the other side as well. If you look at what's happening here, okay, you have a minus 3 here, and if you look at the other side, the same thing is happening, minus 3, and right here where you have minus 2, you have minus 2. If you look at the second example, the same thing is playing out. We have minus 2 and then minus 3 at the bottom, and on the right hand side you have minus 2 at the top and minus 3 at the bottom. So which means that while you are working, you are doing your work back and forth and all of that, you should watch out for things like this so that you don't commit serious errors. Let's move forward. 2 minus 2 is 0 over, here we have plus times, minus times minus is plus, and we have 5 plus 3, which is 8. I won't be writing that in full again, equals y minus 2 over x plus 3. The next thing, of course, is to cross multiply. When we cross multiply, 8 multiplies y minus 2, while 0 multiplies x plus 3. Now, you can open the bracket if you wish. So you have 8y minus 16 equals, there's actually no bracket that you want to open here. There's no point opening any bracket here, because what you have outside of the bracket is 0. So 0 renders anything that is being multiplied by 0, 0. Okay, so everything here goes to 0. Now 8y equals to 16. Divide both sides by 8. Y is equal to 16 over 8, which is equal to 2. So the equation of the line passing through this point is y is equal to 2. Now the question you might be asking is, where did the x go? Where is it? Okay, the x did not actually go anywhere. Okay, if you look at the calculation we made here where we have a 0 as your numerator and your 8 as the denominator, by the time you cross multiply, this 0 goes to x, and this is where the fate of x ended. So that's how x disappeared, if I am to put it that way. I want to believe that is clear, though I cannot hear you from where I am. In the second instance, however, the process remains the same. So I won't want to go over the second example again. You can, when you have privilege, you can go through that yourself and, come up with your answers. And if you have any questions, you can always ask when you have the chance. The next subtopic we are going to be looking at is the intersection of two straight lines. So the idea behind the intersection of two straight lines, again, we're going to be drawing another x and y axis, Okay, so we call this x and we call this y, right? So let's say we have two lines. Okay, we have, this is one line and we have another line. So we have another line. So we're going to call the blue one, we're going to call it line 1, and we're going to call the white one, we're going to call it line 2. Now if you look at line 2, you're going to see that there are a lot of points. So I'm just going to be marking some points here. Point 1, 2, 3, 4, 5, 6, 7 right here, 8. It goes on like that. So there are a lot of points. Okay. And for the blue one, there are also a couple of points that we can mark. Okay. Now you will notice something that is quite unique about this relationship, is that the x and the L2, which is the white line, and the blue line, they have a point where they are, they have a common point of meeting. That is possibly where you have the blue and the white dots, having a kind of an affair, right? So basically, here is where we refer to as the point of intersection of these two straight lines. Because if you look at all of the lines, all of the blue, the white dot, except for this point, every other point go their way. The same thing goes for the blue line. So what I'm saying in Yoruba ni pé gbogbo àwọn point tá mark lórí blue line yìí àti eléyìí tá mark lórí white line yẹn máa rí pé ó ní ibi ẹyọ kan, ibi kan ṣoṣo ní àwọn dot yẹn ti pàdé. Ibẹ̀ la máa ń pè ní point of intersection. So ẹ máa rí pé gbogbo àwọn dot tó wà lórí blue line yẹn oníkálukú dúró. Ìgbà tán dé point of intersection náà ni a lè sọ wípé okay o, ọ̀rọ̀ wọn yíra wọn, oníkálukú dẹ̀ tún bá tiẹ̀ lọ. Okay, so it's just like you are moving to a place and then your friend is moving in opposite direction. So somehow you guys meet each other along the way, and you depart and everyone goes about their business. So which means that for two straight lines there is always just one point of intersection. So how do you do that? If I'm to go back to this diagram, I should tell you that this is the point that satisfies both straight lines simultaneously. Ìyẹn ni pé ibi point yìí nìkan ló dúró lórí line 1 tó jẹ́ blue àti line 2 tó jẹ́ white. So if we are to bring that to the regular application that we need to find the point of intersection of the line 2x plus 3 and line y equals to minus x plus 9, we have to solve the two equations simultaneously. So all you just need is simultaneous equation. I want to believe that it's clear if you are hearing me. So y equals to 2x plus 3 and the other y is minus x plus 9. So if I have to make sense of this, I should have written it as y equals to 2x plus 3. I call this equation 1. And y is equal to minus x plus 9. I call this equation 2. Depending on how good you are with your simultaneous equation, if you are very observant, you're going to see that y equals to is what we have here, and then y equal to is what we have here. So the same y that we have here is the same y that we have here. So we can literally equate equation 1 and 2. Okay, nǹkan tí mò ń sọ Yorùbá ni pé nígbà tẹ́ ti rí pé y is equal to 2x plus 3, y tó wà níbí báyìí náà ni y tó wà níbí báyìí. So nǹkan tó equal sí níbí báyìí òun náà ló equal sí níbí báyìí. So we can just rewrite it by saying that equating equation 1 to 2, if that English is correct. So what I'll be writing here now is 2x plus 3 is equal to minus x plus 9. 2x, this minus comes here, becomes plus, equals to 9 minus 3. So this gives 3x is equal to 6. If you divide both sides by 3, you have 3x over 3, because I know some students like writing it this way, the old way. So x is equal to 2. Remember that your point of intersection cannot be defined by just x. It has to be a function of x and y. Okay, so you have to find the value of y. So you can pick any of the two equations that you have. But yeah, equation 1 and equation 2. So I'm going to use equation 2. So from equation 2, I know that y is equal to minus x plus 9. So y equals to minus 2, because x is 2, plus 9, and y is equal to 7. You see, these are the values that you've obtained while you solve the two equations simultaneously. But your result actually defines the point that we've spoken about earlier, the introduction of this subtopic. Okay, so here we have 2, 7 as the point of intersection. So that's the answer. So whenever you are to find a point of intersection of two lines, in fact, the line might not even be a straight line. Okay, it could be a curve. All you just have to do is to solve them simultaneously. The same thing goes for the second one. The only issue you could have is if you cannot solve a simultaneous equation at this point. Okay, so we have 3x. I cannot solve this completely. Okay, equals 0, equation 1. And 2x plus y minus 5 is equal to 0, equation 2. So the two equations seems to be quite rough. Okay, so you need to make a kind of rearrangement, I beg your pardon, before you can proceed. If you either want to use the method of substitution or you want to use the method of elimination. Okay, so let me just refine it for you a bit before I skip that to the next example. So what I'm going to do here is to I want to use the substitution method, for instance. Okay, and I want y to be on one side, and I want every other one, x and the other ones, to be on the other side. So first, if I want to rewrite this equation 1, I will have to rewrite it as will it be this minus 2, as if since the minus 2y and only minus that 0 so you can have it written as 3x plus 6 is equal to 2y. Okay, which is the same as 2y is equal to 3x plus 6 in yet by. So for the second equation, okay, you can decide to leave y here, okay, since it doesn't have minus, and take both minus 5 and 2x to the other side. So when you do that, the 2x becomes negative and the minus 5 becomes positive. Okay, so if I put that beside this, I'm going to be having y is equal to minus 2x plus 5. Now this becomes your new equation 1 or equation 2, or in certain cases you find them writing it as equation 3 and equation 4. But remember that your equation 3 is your equation 1 in disguise, and the same thing goes for equation 4. It is equation 2 in disguise. Now I leave you in the hand of your understanding of the simultaneous equation to solve this. Before I proceed to the next question, there might be someone there saying that, what if I don't like substitution method? Okay, what if I want to use elimination method? It's all good. As a free word, you can use the elimination method. Okay, so if you want to use the elimination method, you just have to, from here, it could be from here, okay, from here you can rewrite what you have here as 3x minus 2y equals to minus 6, and then this is going to become 2x plus y equals 5. Then you choose which one of x or y you want to eliminate. I want to believe that I have helped someone before I proceed to the next question. Or would you like me to solve the equation? if you want me to solve the equation, you can react, and if you think it's not really necessary, then we can proceed to the next one. No reactions? Nothing in the comment box? Nothing? Okay, great. So since there are no reactions, then I move on to the other part of the question. Now, at the beginning of our lesson today, I have talked about how you can obtain the equation of a straight line when you are given 2 points. Okay, if you look at how we started the class, given 2 points. So we have 2 points, then we produced a straight line. Here we have 2 points again. We produced a straight line. The same thing goes for the class exercise that I gave to you as well. We also produced a straight line. Now in this question, we have L1, which is the first line. L1 is a function of 2 points. Okay, point A, which is 1, 2, and point B, which is 3, 6. And we have another line, L2. Right. So L2 is also a function, okay, of 2 points C and D. So C is 2, 5, and D is 4, 1. Remember that these two coordinates defines this line, and these two coordinates defines this line. So I don't have a method that you can use to obtain the point of intersection directly, other than the one that I'm about to explain. Now you are going to use your understanding of finding the straight line given 2 points, okay, to derive the equation of the line L1 and that of L2. So without wasting much of our time, let's go straight to business. So here is going to be x1 and here is going to be y1. Here you're going to be having x2 and here you're going to be having y2 as well. And we use your y2 minus y1 over x2 minus x1 equals to y minus y1 over x minus x1. y2 is 6, y1 is 2, x2 is 3, x1 is 1. And this is equal to y minus 2 over x minus 1. 6 minus 2 is 4, and 3 minus 1 is 2. This is equal to y over 2, then over x minus 1. Clearly, 2 can divide 4. Okay, so we have 2 over 1 equals y minus 2 over x minus 1. When you cross multiply, you have y minus 2 multiplying 1, so that's y minus 2. And for this, because this is 2, you have to use your bracket, x minus 1. Sorry for the noise that is coming from the background, it's from my neighbors, right? Okay, so y minus 2 is equal to 2x minus 2. And I can take this minus 2 to the other side. So y equals to 2x minus 2. Sorry for my inconsistency with the x, okay, plus 2. So you have y is equal to 2x plus 0, because minus 2 plus 2 is 0. So this is for line 1. For line 2, you repeat the same process: x1, y1, x2, and y2. Right, so the formula again: y2 minus y1, x2 minus x1 equals to y minus y1, x minus x1, so that you don't say that you can't recall the formula. Your y2 is 1 and your y1 is 5. Your x2 is 4 and your x1 is 2. This is equal to y minus 5 over x minus 2. 1 minus 5 is minus 4. while 4 minus 2 is 2. Just like before, only for the fact that this is negative, minus 4 divided by 2 gives minus 2. So you have a minus 2 over 1 equals y minus 5 over x minus 2. Cross product or cross multiply. See, you have y minus 5 equals minus 2 times x minus 2. So you have y minus 5 equals minus 2x plus 4. So y equals to minus 2x plus 4 plus 5. So y equals minus 2x plus 9. Now we can conveniently say that we have an equation 1 and equation 2. This is your equation 1, which is line L1, and this is for L2. This becomes your equation 2. Okay, so y equals to 2x, equation 1, and y equals to minus 2x plus 9, equation 2. Okay, so equation 1, equation 2, so it's more like a ritual. Right, so again, this type of simultaneous equations are very easy to solve because you can see that this is y equals to y equals to. Okay, so I can basically equate 2x to minus 2x plus 9. So I have 2x equals minus 2x plus 9. So here we have a 4x equals 9. I have taken this minus 2x to this side. It becomes plus. So we have x equals 9 over 4. Easy. Okay, so to find y, because like we've said that one point is not enough. I mean, one part of a coordinate is not enough to tell a point. So we need to find y. So you can use either of equation 1 or 2. So of course, equation 1 seems to be easier to work with than 2. So from equation 1, we have y equals to 2x or 2x. Okay, so y equals to 2 times 9 over 4. You know, now this 2 divides this 2, and then we have 9 over 2. In the end, x equals 9 over 4 and y equals 9 over 2. And now we can safely say that the point of intersection of these two lines that has been giving us trouble since morning are 9 over 4 and 9 over 2. So this is the coordinate. So let's call this, we cannot call this L, so you can choose anything you like. So let me just call it x. So this is the coordinate of the point where L1 and L2 intersect. I just want to believe you understand what I am saying from here. So yeah, that is basically it. If you want me to go over this again, or probably I cannot explain everything from the beginning, but if you think that there's an area that needs clarification, please let me know before I move on to angle between the straight line and the x-axis. I don't know if I should I open the microphone? Should I allow microphone? Let me know in the comment section, and if it is not necessary, then we'll move on to the next subtopic. Sanusi Buronke, it shows here that you are raising your hands. I think you should just leave your comment in the chat box. Right, it seems we have someone saying we should move on. So someone said it's not necessary. Okay, so great. So let's move on to the next part, because we have been dwelling too long on this part. Now we are looking at the angle between a straight line and the x-axis. Okay, so it is becoming a little bit should I say it's technical? No, not really. It's not really technical. All right, so the angle between a straight line and the x-axis. To do that, again, we have to go over what we've been drawing since morning. So here we have x, it has not changed, and here we have y, it hasn't changed. So we draw a line again. Okay, we draw a line as always. So what we want to learn is the angle that you have right here, which is theta. Okay, I have a little explanation to make here, and I want everyone to pay a good attention to what I'm about to say. You see, to obtain the angle between a straight line and the x-axis, you can use, if you have an equation already, you can use the equation to find the angle by extracting the slope. Okay, let's first do that. Let me show you something. So let's say you are trying to find the equation, the angle for this. Let's say you have a point here again. Let's call this x2, y2. Sorry for writing that first. And let's say we have another point here, x1, y1. So let's call this x, let's call this y. Okay. Yeah. So as always, we connect what we have on this side and what we have on this side together. And we have an angle of 90 in between them because it's a right angle. So here we have y2 again minus y1, and here we have x2 minus x1. Now, I want to bring this to your attention that the dotted line that I have drawn here is parallel to the x-axis. So if it is parallel to the x-axis, it means that the angle this line makes with the x-axis is going to be a corresponding angle with the angle that you have here. So which means that what you have right here is the same as what you have right there. So any operation that you perform with the angle here is going to be working for the angle here. In fact, if we produce another thing here, another line here, it is also going to be working with the angle that you have here. So it's just more like how it is. Here we have m again. Okay, so as always, m is equal to y2 minus y1 by x2 minus x1. I hope you are not tired of this formula. Okay, now if you look at where our y2 minus y1 is, you're going to see that it is on the opposite of the right angle triangle, and your x2 minus x1 is the adjacent. So you have opposite versus adjacent. So if you remember your SOHCAHTOA, this means tan. Okay, so this is equal to tan theta. Now we can extract this by eliminating this. Since it's just a straight line, it's not as if we have 2 points given. All right, so we can just remove this guy out of the equation. Okay, and then this becomes m is equal to tan theta. Now in this context, we'll be dealing with the absolute value of m. Okay, so tan theta is equal to the absolute value of m. I have explained what absolute values are in class. It's just working with the magnitude and doesn't have anything to do with the direction, either it is positive or negative. And I also said that if you have the absolute value of -2, for instance, the answer is 2, because what absolute value is saying is that if I have 0, I have -1, and then I have -2. Absolute value is saying that how many steps will I have to take from 0 till I get to -2. So this is 1 step and this is 2 steps. So it is just that 2, the number of steps that you have, that becomes the answer. Okay, not disregarding whether it is negative or it is positive from that point of view. So this forms the basis of anytime you are trying to find the angle between a straight line and the x-axis. I am going to explain later, because the reason why I use this absolute line, you are going to see as we proceed. But I also want to believe this is quite clear. Let's move on. I want to believe that this m You also know what it is, that it is the slope or the gradient of a straight line. So let's look at the first example. So we have y equals x plus 1. How do you find the angle this line makes with the x-axis? Okay, so basically, if I draw again, I don't necessarily have to draw in this case, but you know, for the sake of clarity, y, x. So if I draw a line, okay, this is it's going to be like this actually. Okay, means that I'm trying to look for the angle that is here. So I can take any point in time and say that it is the same angle here, and I can take it as the same angle that is here. So all I need is, okay, let me try to match my y equals to x plus 1 with y equals to mx plus c, because all I need is my slope. Because if you look at the formula, you have tan theta is equal to the absolute value of m. Okay, so here m is equal to 1. If m is equal to 1, remember that tan theta is equal to the absolute value of m. So tan theta is equal to the absolute value of 1, which is 1. So theta is equal to arctan 1. Arctan 1 is 45. Therefore, the angle y equals to x plus 1 mixed with the x-axis is equal to 45 degrees. It's as simple as that. It's not that difficult. Now, why I use the absolute value is because this absolute value only gives us an angle that is acute. What is an acute angle? An angle that lies right in between 0 and 90 degrees. Okay, so that's why we are using that. So let's look at the second instance. X plus 4y is equal to 12. X plus 4y is equal to 12. This obviously is not in the form y equals to mx plus c, so we have to rearrange and say this is 4y is equal to by the minus x plus 12. So y equals to divide through by 4, minus x over 4 plus 12 over 4. Y equals, here we have a 1, so we can just bring the 1 here, plus 3. Now let's put that side by side with our existing equation. So y equals minus 1 over 4x plus 3. From here we can easily extract our our slope, which is m. So m equals to minus 1 over 4. Minus 1 over 4 is negative 0.25, if I'm not mistaken. So tan theta is equal to the absolute value of minus 0.25. Tan theta is equal to 0.25, remember. Lastly, theta is equal to arctan 0.25. Let me use my calculator for that, and the answer is 14.04 degrees. So this is the acute angle for that. So it's as simple as that. It's nothing really complex. So I want to believe everyone understands that. All you just have to do is to write this in the form y equals to mx plus c, and that's it. Since we have covered a lot today, I am going to proceed actually to the next subtopic. So now the next one says that how do we find the angle between two straight lines? Okay, so again, I draw as always. Draw every time. Okay, I draw. Is this not too big? Please let me redraw. Okay, right, so this is better. Please note before I proceed that I'm about to explain a concept that may be very, very difficult for you to grasp if you don't have a very good knowledge of trigonometry. But don't worry, all you just have to understand is the final formula. Now if you have a straight line, okay, I draw a straight line. This is the first straight line, and then we have another straight line. So this is more like L1, okay, and this is more like L2. Your L1 is going to have a slope of M1. Because I can differentiate the slope méjèèjì. So line 1 slope is M1, while line 2 is going to have a slope of M2. Remember the angle that we are calculating, angle connected with the x-axis, okay? So angle T L2 make with the x-axis ni L2 make with the x-axis. When you write English, all right, theta 2, and this one is going to be theta 1. Now, since the angle between two straight lines ni I'm a let me explain a bit. So àlàyé lele ká sọ pé irú x-axis tó wà nísàlẹ̀ náà la tó dá padà sókè mi báyìí, since tó ti jẹ́ pé a ní irú line, so láti bí báyìí sí bí báyìí òun ni theta 1, láti bí báyìí sí bí báyìí òun ni theta 2. So this is theta 2, this is theta 1. Tẹ́ bá wo àárín méjì yìí, ibi kékeré yìí, ibi báyìí, ibi angle kékeré, ẹ máa rí wípé tẹ́ bá yọ theta 2 kúrò nínú theta 1, òun ló máa fún wa ní angle tó wà ńbẹ̀, okay? So ẹ jẹ́ ká pè angle yẹn ní theta. Ẹ má bínú o, mo pọ̀ tí máa fẹ́ gbomi mu báyẹn, okay? So a ti sọ pé theta máa jẹ́ theta 1 minus theta 2. Now, for those that have strong knowledge of further mathematics, we take the tangent of both sides. We have tan theta is equal to tan theta 1 minus tan theta 2. I can be tan saying méjèèjì ni. So now, okay, so nínú trig, there is a trigonometric identity that says that if you have it this way, okay, tan theta, this is going to be equal to, ní láti mọ̀ ṣáàjẹ́ kí n kọ́ tan theta 1 minus tan theta 2 over 1 plus tan theta 1 tan theta 2. Okay, I know there should be no controversy. Okay, now ẹ má gbàgbé pé nígbà tá so ẹ ṣáàjẹ́ ká máa wọlé báyẹn. Okay, don't forget that while we were discussing about this thing, we said tan theta is equal to m. Okay, so which means that for this m1, it's going to have tan theta 1, and for m2 you're going to have tan theta 2. So which means that m1 is equal to tan theta 1, and wherever I see m2, I can say it is tan theta 2. So which means that everything that I have here can be rewritten as tan theta is equal to, tan theta 1 is m1, so m1 minus tan theta 2 is m2 over, okay, 1 plus m1 m2. Now because we are talking about the acute angle, okay, we have to put the absolute sign. So which means that the angle between two straight lines can be obtained by using tan theta is equal to the absolute value of the difference between m1 minus m2 over 1 plus m1 m2. So don't worry, all you just need to master is this formula right here. So I will be stopping for today's class because our time is spent already. By next week, I will explain how you can apply this formula. And even if you don't want to apply this formula, there is another way out. I know someone is saying, oh, well, okay, there's another way out if you just don't like this formula, okay. So I'll be ending now, and I'll be taking your requests probably in a minute or two before it ends, because
it's
we have
21
about
hours.
less than 3 minutes to end our class.